Alright guys, here we go. We are going to talk about Chapter 8, Pure Competition in the Short Run. As I note here, pure competition is really important, so everything that we do here in Chapter 8 is going to be a very big deal. So please do a good job, pay attention. Here we go. So we are now going to get into the four market structures. Okay, and the first one that we're going to study, so this chapter, is about pure competition. Then we also have pure monopoly. So you guys are familiar with monopoly, not just for the board game, but also for kind of the whole deal. The idea of one seller. Monopolistic competition is a little bit different, and then there's oligopoly. Now what we have to do is think about this in terms of a continuum. So we've got pure competition all the way down to pure monopoly. So you'll notice that at the one end is pure competition. This is where there is a zillion firms basically producing the same stuff. Then at pure monopoly, you have one firm producing everything. Monopolistic competition is close to pure monopoly in that there's lots of sellers, but it's different from pure competition because the things that they're selling are not all the same. So think about maybe like burger joints, right? So burger restaurants, you've got, and I'm not talking about fast food places. I'm just talking about like your corner places, like, in all those places in downtown Kirkwood where you can go and you can get a $9 burger, right? So monopolistic competition, all those little corner restaurants. Then there's oligopoly. So an oligopoly, now, and to finish monopolistic competition, all those burger joints are similar, but they're not the same. The burgers are a little bit different at Mike Duffy's than they are at PJ's. In those, obviously those are two restaurants in Kirkwood that are basically right across the street from each other. They're similar, but they're not exactly the same. Then you've got oligopoly. So this would be like, the soft drink market, Coke and Pepsi. That's really just a couple of choices. And whether they sell the same thing or different things doesn't really matter very much. So these are our four market structures. We're going to concentrate on this first, then we'll learn about pure monopoly, then we'll learn about monopolistic competition, then we'll do oligopoly. And the reason that we go in that order will make more sense to you as we move along. Okay, so this right here is a really nice chart. It takes all four and it looks down this list of characteristics. Uh-oh. So these characteristics are what become really kind of important. Okay, so the number of firms, the type of products, the control over price, conditions of entry, and non-price competition. I'm not going to go through this whole thing with you, but this is really what we're going to be concentrating on. So it's very important that you spend time, and then you can consult the text for a lot more in-depth look at what this chart means. My guess is, though, when you read it, it'll make good sense to you. Okay, so we're going to study pure competition. So basically what we're doing in this slide right here is we are going through this. Okay, so this is the other reason that I'm not going through it. We'll do all of these things. We'll do all of these on this slide for each one. Okay, so here are our characteristics. There's a large number of sellers. So I said, a gazillion, I think was my deal. A standardized product, meaning that, if we talk about farming, that's a typical example here. Corn from Farmer Bob is the same as corn from Farmer Dan. And when you go to Schnucks and you buy an ear of corn, you have no idea where it comes from. And, we had our example of the two burgers from Mike Duffy's and PJ's, and they're similar but not the same. Corn from Farmer Bob and Farmer Dan, that's the same. They're price takers, which means that they do not get to set the price for their goods or services. That is set by the market. There's easy entry and exit, right? So this is kind of the lemonade stand idea. As soon as it seems like a good idea to run a lemonade stand, everybody will do it because there's easy entry. Once it's not a good idea any longer, you're not making the money you want in a lemonade business, then you exit because it's very easy to do that. This is the part that's really significant, okay? Perfectly elastic demand. What that means is when you're drawing out your P and Q, you have a demand curve that is perfectly flat. This is perfectly elastic, excuse my poor drawing, but it's perfectly elastic. It's a straight, flat line, meaning and we talked about this before, but the price at this quantity is exactly the same as the price at this quantity. Okay, so if that's, $10, then it's $10 to sell quantity 1 and $10 to sell quantity 100. That's what perfectly elastic demand means. Keep in mind this is theoretical, but that's what it is. We're learning this theory because it's the left edge of the continuum. So next, the firm can produce as much or as little as they want at that price. This firm can sell 10, or it can sell 100, or it can sell 1,000,000 because the market is going to absorb all of it. Because Farmer Dan and Farmer Bob, as big as their farm is, they are but a drop in the bucket compared to all of the corn that the world produces. Okay, and then we see that it graphs as a horizontal line. So now we're going to talk a little bit about the revenue side of things. And let's look here. So our average revenue is basically revenue, total revenue, divided by Q. Okay, that's going to be average revenue. Now what we're going to notice is that average revenue is also equal to price. So think about that. Because price is, revenue, total revenue is still P times Q, right? That equals total revenue. So therefore we know, one property or another, total revenue divided by Q must equal P. Okay, so we all know that. And that's going to give us average revenue, total revenue divided by Q. But it's also going to give us P. Therefore, P and Q must be equal. That's going to be important. File that one away. Marginal revenue, this is the same definition as we've had before. With each additional sale, right, so we sell one more unit, what is the extra revenue that we get? And that's our formula. This should be familiar to you from before. The change in total revenue divided by the change in Q. And just like before, our example, changes in Q will often be 1, but don't get too hung up on that. And remember that if the question is asking you about a change in a Q that is not 1, then you can't just assume that it's the change in total revenue when you add one more, because you're dividing by, typically that's what it is. You can just subtract because typically the denominator is 1, but it doesn't have to be. We learned that before, just a little reminder. All right, so now let's look at a little bit of this stuff. So we're going to get our firm's demand schedule, which is going to be made up of average revenue. Okay, so in this example, what they're selling sells for $131. Okay, so that means that in this perfectly elastic demand curve, right? So this is D, and it is a horizontal line. It is equal to average revenue, right? Because demand, remember, is always the same as price. Okay, so over here what we're seeing is price at these various quantities, and the price is always going to be $131 because we're selling identical things. So if somebody wants to sell for, this price right here, then they're going to sell 0 products. They're going to sell exactly none, because there's absolutely no reason for anyone to spend this price when they can get an infinite quantity at this price, right? Likewise, nobody's ever going to sell for this price here because they would sell exactly the same at this higher price. You remember that from our discussion of perfect elasticity, okay? So we have our horizontal demand curve, and we know that demand equals price, okay? And we know that price equals average revenue. Now, the one interesting thing is that marginal revenue is also equal. So this is kind of the magic of a purely competitive firm, that demand equals marginal revenue, which equals average revenue, which also equals price. Because the demand curve is always going to tell us the price at a particular quantity, right? So typically what we see is, I'll do a little one here. Typically, you've got a demand curve that slopes downward like that. And what we do is we draw here and then here, right? And what we see is at these various quantities, right, at Q1 and Q2, we have P1 and P2, okay? So the demand curve tells us the price. Here, now we have our horizontal demand curve. It is still telling us the price. What it's telling us, since it's horizontal, is that the price is always the same, okay? No matter whether you're selling 10 units or 4 units, doesn't matter, it's still going to be $131. Now, since that's the case, when you sell one additional unit, you're always going to sell it for the same price, so marginal revenue is the same as well. The additional revenue earned by selling one more unit, since the one more unit will be the exact same price, you sell the first for 131, and the second for 131, and the third for 131. So your total revenue is just going to be price times quantity, right? So 131 times 2 is 262. Now, marginal revenue, when we add that in, what we see is it's always 131, okay? So that's what we're learning here. You can pause and rewind if you have any questions. My hope is that that makes good sense to you. Okay, so now we're going to start having a more significant discussion. We understand what the graph looks like, and we're going to ask ourselves 3 questions. The first, should the firm produce? The second, if they should produce, how much? And if they produce a certain amount, what will their economic profit or loss be? Those are our 3 questions. Here we go. Wow, big full chart. So what this is now is basically the profit maximizing output for a purely competitive firm. We're going to use the total revenue minus total cost approach. Now you guys know this because I've already talked about it. So we said, you know, we had our graph where we had total revenue and total cost, and it looked something like that, right? And then we had our profit. Now imagine that these things line up. So here's total revenue, right? Total revenue peaks. This should line up right here. That's close. Total revenue peaks there. But we said that the peak of total revenue is not necessarily the most profitable point. Instead, what we said was that the most profitable point is the greatest vertical distance. Remember? So that is an illustration of the total revenue minus total cost approach. Okay, and you should remember when we had those several different graphs kind of stacked on top of each other from 2 chapters ago. Anyway, let's get rid of that. And what you're going to see now is we'll put in our total fixed costs. Okay, so we're adding cost. We had revenue information because our price is $131, right? So that's going to give us all of our revenue. You are given the fact that total fixed cost is $100. Notice that it's constant. Okay, so it is fixed, it's constant, it is independent of quantity. So it's $100 no matter what. Our variable cost, 0, when output is 0. That should seem familiar. And then it's going to rise. Okay, so our total cost, which is TVC plus TFC, so column 3 plus column 2, that should be a plus sign, equals 4, column 4 that is. So you're just kind of adding across here. Okay, so that's going to give us this. Then our total revenue is just going to be P, 131, times Q. Okay, so 131 is price times quantity. Then for price times quantity 2, we get 262. Okay, shouldn't surprise anybody. Now and then we just kind of work our way down. Well, when we produce nothing, we sell nothing, we have 0 revenue, but we still have our fixed cost. So we're going to lose, if we produce nothing, we will lose $100. On the other hand, if we produce 1, we will sell, or we'll raise $131 when we sell that one good, but our total cost is $190, meaning we'll lose $59. So we're just going to subtract this category, or this column, from this column. And then we're going to produce where our number is biggest. And you see that at 9 units, we have a total cost of $880, a total revenue of $1,179, giving us almost $300 in profit. If we make the 10th item, then we only make $280. And remember that businesses are trying to maximize profit. So this is where they're going to produce. Moving on. So let's see that graph. Now, because we're in a purely competitive market, our total revenue curve is going to be straight up. Okay? Often, if we're not in a purely competitive market and we don't have that horizontal demand curve, then what we're going to see is a slopier, a curvier total revenue line. Now we're going to add in the total cost curve. So this second curve here is reflected in what we saw just based on the total cost, the total fixed cost of $100 and the total variable cost, which obviously changed as production changed. Now we said before, using the total cost minus total revenue, or total revenue minus total cost method, that at 9 units, that was our greatest period of difference between the two. And we're going to see that it's a little hard to tell, but that's also the greatest vertical distance between those two things. And then our economic profit peaks at the same point. So this one line, and that should have lined up, sorry, drawing with the mouse is not that easy. All of that lines up well. So there's our total cost, total economic profit. Here we have 2 break-even points. Okay, that's going to be kind of important, the 2 break-even points. So we could produce 3 items, or right around 3 items, and break even, or we could produce around 13 items and break even. So the intersection of the revenue line and the cost line are going to be our break-even points. As long as we produce somewhere in between, then we have this period here. If we produce anywhere, we're going to profit. But remember that our desire is not just to profit. Our desire is to maximize profit, and maximum profit is going to be at the greatest vertical distance, right? So just on the profit curve, it's going to be where the profit curve peaks. But when we've got these 2 curves, it's the greatest vertical distance between the 2 of them. Now we're going to get into a slightly more complicated approach. This is the marginal revenue, marginal cost approach. And I'll tell you, this is incredibly important. Businesses want to produce where marginal revenue equals marginal cost. Say that out loud. Businesses want to produce where marginal revenue equals marginal cost. So we're taking that same chart that we had, but we're adding in marginal revenue and marginal cost. What this means is we have a constant marginal cost curve, okay? A constant marginal revenue curve, because in a purely competitive market with a horizontal demand curve, marginal revenue equals demand, which equals average revenue, which equals price, okay? But on the marginal cost side, we learned in class the other day that the marginal cost curve looks like some sort of check mark, right? So marginal cost is going to look like that. It's going to initially go down because of the moment of increasing marginal returns. Then it's going to bottom out, and then it's going to start to rise because of diminishing marginal returns. Okay, so in our example of the restaurant, that was when we hire the second waiter makes the first waiter more efficient, which is why their average marginal product, so we're talking about marginal product, not marginal cost, but it's the same thing, is they're going to become more efficient. And that's why we said that the marginal product curve is the inverse of the marginal cost curve. And at the same point where marginal product peaks is where marginal cost bottoms out. This is increasing marginal returns, and this is diminishing marginal returns. Okay, so kind of remember that. Now what we're going to do is, this gets back to if I give you 131 and it costs you 90 bucks. Do you take that deal? Yes. If I give you 131 and it costs you 80, do you take the deal? 131 and 70, do you take the deal? Now all of a sudden we're getting down here and it's starting to go back up. I give you 131, it costs you 90. Yes, you take the deal. 131 and 10, 110, you take the deal. 131 and it costs you 130, do you take the deal? You sure do. Then 131 and 150, now you stop. If you're not going to accept $131 if it costs you $150 to make that $131. So what we see is where marginal cost equals marginal revenue, or comes closest to it, that's where we want to produce. Once selling, making, creating, whatever, that additional thing costs you more than you gain when you sell it, then you want to stop. This is going to be the approach that we use more often than anything else, the marginal revenue, marginal cost approach. Okay, so just remember that. It's this, and we've already talked about that. We talked about marginal benefit and marginal cost and the whole, if I give you $10 and it costs you $5, then you take the deal. We just walked through that same rationale right here. So now that we have marginal revenue and marginal cost information, we can make an output decision. So here we're graphing our marginal revenue. We know that marginal revenue equals price. We know that it also equals average revenue and it also equals demand. Now, our marginal cost curve, and you can go back and plot all of this out if you want to, right? But this is the shape of the curve. It's always in that kind of check mark shape. And what we see is right here where marginal cost equals marginal revenue, that's the magic, right? And that lines up with 9, which is what we've said in all of our approaches is the quantity that we're going to produce, where marginal revenue equals marginal cost. That intersection is going to be incredibly important all throughout the rest of microeconomics. Now we add in average variable cost, and we add in average total cost. Okay? Now this is going to be important. So we know where we're going to produce. The intersection of marginal revenue and marginal cost tells us what we will produce. The demand curve, which is equal to price and equal to marginal revenue, that tells us the price. Okay? Now, what we're going to do is look at average total cost at the intersection of the imaginary line that goes through marginal revenue equaling marginal cost. In between average total cost and price. Okay, so you kind of saw this before when we were drawing those areas. So think about it. If we're making 9 units, what we do is take total cost and divide it by 9, right? And obviously total cost divided by Q is the definition of average total cost. So we've got 9 units and it costs us about $100 per unit. We're selling for 131, which means we make about a per unit profit of $31 per unit. Okay, so 31 times Q of 9. So this area becomes our area of economic profit, the green area. That's good. All right. We're going to stop right here. So we'll stop at the profit maximizing point. Hopefully that makes good sense. I wish you guys the best of luck.